Hello boys and girls, welcome to lesson 5-4, polygons and angles. In this lesson we will continue to talk about algebraic concepts and how they can be applied to geometry, as well as we're going to look at the word polygon, which it's essentially a closed figure made of two or more line segments, and equiangular, which is just the way it sounds. I took the word equal and angle and put it together as one word. It's when all angles are equal in a shape, in a polygon. And a regular polygon, which is the ones that we typically know: rectangle, square, triangle, and so on. Vocabulary startup. A polygon. A polygon is a simple closed figure. Closed means it's not like a U or a V. All the line segments connect, right? And it closes the figure. And formed by three or more line segments. The segments intersect only at their endpoint. Okay, so at their endpoint. So it's a closed figure, like a square or a rectangle. Here we have the United States, okay, the map of the U.S. And they want us to take a look at the states, right? And you can see in here some of them are perfectly shaped, right? You see that? A map of the United States is shown. List the states that are in the shape of a polygon. Then list the number of segments that form the polygon. Okay, so we can see here, well, for example, this one you can tell is kind of separated, Washington and Oregon, by a river, right? And over here as well with Montana and Idaho. And then this area right here, it's just one big mess. But once we start getting into, this would have been the Louisiana Purchase, okay, a lot of this, and this would have been what was acquired from Mexico. We start to see straightly shaped polygons, right? Except here, maybe this, when they're winding like this, they're usually separated by a river, as you can see here along the border of Texas and Mexico. So let's start. We have to name the state and the number of segments. Let's zoom in a little bit here to New Mexico, okay, where I can count. I'm going to start on the top. I have 1, 2, 3, 4, 5, 6, 7, 8. You can see there that we had a couple like steps sort of to take down. So we have New Mexico with 8. Let's take a look at another one. I see over here, Colorado looks like a perfect rectangle, and so does North Dakota, a perfect rectangle almost. I see Utah right here with, again, I'll start at the top. 1, 2, 3, 4, 5, 6. Okay, let's look at, well, as I just mentioned, Colorado. It's a perfect rectangle, right in the middle, essentially in the middle of the country. Kansas seems like it's more in the middle of the country. But Colorado has 4. Okay, North Dakota, as I mentioned earlier as well, North Dakota has 4. I'm not going to write it down, I'm just going to point it out, but if I could, I would continue my list. And then I see Wyoming. Right there also has 4. You see those chunks of land just perfectly laid out. These came later on in the development of the United States. Okay, we have a formula here that we want to look at, which will help us identify the number of angles, or the sum of all angles inside of any polygon, and that is n minus 2 times 180. So this n minus 2, n represents the number of sides. See the number of sides that we have, and then we have to subtract 2 and multiply by 180. Okay, so the sum of the measures of the interior angles of a polygon is bracket n minus 2 bracket 180, or you can say a minus 2 times 180, where n represents the number of sides. In symbols, we say right here the sum of all angles equals n minus 2 in parentheses times 180. Before we move on, I want to note that this is something you need to memorize. Make sure that you understand that you take the number of sides and you subtract 2 and multiply it by 180. You can also use the sum of the angle measures of a triangle to find the sum of the interior angle measures of various polygons. A polygon that is equilateral, all sides are the same length, and equal angular, all angles have the same measure, is called a regular polygon. So here we go. Okay, number of sides 3. Here's our triangle. Okay, and then number of triangles. You see, this is just one triangle in here, which equals 180. Over here we have an irregular polygon, right, where we have, if we were to slice it down the middle, okay, we have two triangles, and each triangle is 180. So when we measure all the possible angles inside, we have 360. We have another one here where we count the sides, right? 1, 2, 3, 4, 5. 5 sides minus 2, right, would be 3. And 3 times 18, 3 times 18 would be 54, or 3 times 180 would be 540. Just add in the 0, right? Or simply just make 3 triangles. Each triangle, you know, equals 180. That's the sum of 180 degrees. Multiply it times 3, you get 540. And then finally, again, 1, 2, 3, 4, 5, 6. 6 sides, right? Minus 2 would be 4. So you essentially have 4 triangles, and you have your 720. Example 1. Now we can either do it either way. We can count the number of possible triangles, or just simply use the formula we've been given. The number of sides minus 2 times 180, because 180 is, when we subtract 2, we're just essentially counting the number of triangles in it, and we multiply each triangle times 180 to get the sum of all angles. So find the sum of the measures of the interior angles of a decagon. Well, we know that a decagon has 10 sides. So we replace our variable with 10, subtract the 2, we get 8, and 8 times 180 is 1,440. The sum of the measures of the interior angles of a decagon is 1,440. Okay, if you think you got it, try these right here. We have hexagon, which has 6 sides, octagon, which has 8 sides, and 15gon. I'm not actually sure how to say that one, but try it with these. Okay, go ahead, pause the video. Okay, let's try the hexagon. Remember to use the formula where you have n minus 2 times 180. Okay, and we solve for this by simply replacing our variable. So a hexagon has 6 sides, and we're going to replace it, and then we continue on with the sum of all angles. 6 minus 2 is 4, so we have 4 times 180, or 4 times 18, and then you can just add the 0. And I know that 4 times 18 is 72, or in this case it's 720 degrees. Okay, let's try the next one, an octagon. Again, write down the formula, and let's replace the variable n. It's an octagon, which is 8 sides. And then we go ahead and we solve. So the sum of all angles, a minus 2 equals 6 times 180, or you can say 6 times 18, which is 108, but then you add in the 0, and it becomes 1080, right? 1080 degrees is the sum of all angles inside of an octagon. Okay, now let's try the 15gon. So I start with my formula, I replace my variable. I know that 15 will be here. 15 minus 2 is 13, so I skipped one step when replacing the variable. And then I multiply 13 times 180, and when I do that, I get the sum of all angles is 2,340 degrees. Okay, now let's apply what you've learned to solve word problems. Here's example 2. Each chamber of a bee honeycomb is a regular hexagon. Find the measure of an interior angle of a regular hexagon. So here we go. We've got a hexagon has 6 sides. We subtract 2, we get 4, and it equals 720. Sorry. The sum of the measures of the interior of a hexagon is 720 degrees. So now divide 720 by 6. the number of interior angles to find the measure of one interior angle. So you want to know the measure of one of those angles, you just simply divide it by 6. So the measure of one interior angle of a regular hexagon is 720 divided by 6, or 120. There we go. So each side, each angle inside of a hexagon, a regular hexagon, is 120. Now that we know that, let's solve these: an octagon, a heptagon, and a 20gon. Octagon, 8 sides. Heptagon, 7 sides, and 20gon. Go ahead and pause the video now. Okay, so for an octagon, I'm going to go ahead and just replace. I wrote down my formula that we've learned, where n minus 2, but I'm not going to write n. I'm just going to go right to replacing my variable with my 8. So 8 minus 2 equals 6 times 180 will give me the sum of all my angles, right? But now I want to know one of those angles, so I'm going to divide it by 8. Notice I put everything under 8. So I will solve and then divide. And when I do that, I have 6, as I mentioned right here. 8 minus 2 is 6. And then 6 times 18 gives me 1080, or sorry, 108, or 1080. If I multiply by 180, I have S equals 1080 divided by 8. And we get the sum of all angles is 135. Or not the sum of all angles, but one angle is 135 inside of a regular octagon. Okay, heptagon, 7 sides, same thing. We follow the same procedure, and 7 minus 2 is 5, and 5 times 180 is 900. But remember that we have to divide all of this. Okay, we have to divide all of this by 7 so that we can get the angle for each angle inside of a heptagon. So as we mentioned, 7 minus 2 is 5, and 5 times 180 is 900. So now I have 900 on the top divided by 7. And when I divide 900 by 7, I actually get a decimal number. So I'm going to get, my angle is 128.6 degrees. Okay, and finally a 20gon. In a 20gon, do the same procedure where I replace my variable with 20. I solve for that, and I get 18 down here times 180. Okay, divided by 20, correct? And that's going to give me 3,240 divided by 20. And when I divide that by 20, I get 162. So each angle inside of a 20gon is 162 degrees. And here's our other key concept for today's lesson: exterior angles of a polygon. And as you can see here, we have a pentagon, right, with 5 sides, 1, 2, 3, 4, 5. But really what they're looking for is the angle on the outside. If you continue with the transversal line, right, it'll create, in each line you create a straight. You see that? And then you have these lines, they create an angle, right, in each side. So what we're doing is, in words, the sum of the measures of the exterior angles, one at each vertex, is 360. So at each vertex we have 360 degrees. Okay, so measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 equal 360. So because we get our full circle there, right? So take a look here. We have 120, 140, and 100. Right here we just have, you can see that it's slightly over 90 degrees, so it's 100 as well over here. An obtuse angle of 120 and another one of 140. When you find the sum of all three, you get 360. Here we have 4 of them, okay? And again, when you find the sum of all 4 angles, you also get 360. Example 3. Find the measure of an exterior angle in a regular hexagon. So regular hexagon, all the sides are equal, right? And all the angles are equal. And they want us to find the one of the exterior angles. Now, we don't know what they are, but we do know that a hexagon has 6 sides. And we do also know that the sum of all angles around the outside equals 360. So we simply do all 6 sides times x times a value that we do not know, because we don't know the angles, is going to equal 360. When we divide both sides by 6 to isolate the x, we get 60. So each exterior angle of a regular hexagon measures 60 degrees. Now we can try this on our own. Right here we have 3 examples. We have find the measure of an exterior angle of each regular polygon. A triangle. So a triangle, now we're looking for the exterior, don't forget. A triangle will equal 6 sides, right? So we have, 3 sides. So we have 3x equals 360, right? The quadrilateral's 4 sides. So we have 4x equals 360. And an octagon has 8 sides, so it's 8x equals 360, right? And when we do that, we're going to use division property of equality, so we can isolate our x, and here we get 120. Here we use it again, division property of equality, and we get 90. And then again, right? Both sides divided by 8, 8's are gone, and we get 45. 120 degrees, 90 degrees, and 45 degrees, and that's how we find for a regular polygon. You see, regular polygon where all sides and angles are equal. Okay, here is our guided practice. Please take a look at it, go through it, make sure you feel comfortable, and if you have any doubts or questions, you can always go back to the examples in the video or simply bring your questions to class. See you then, everyone.